Hey guys, welcome back. So in the last tutorial, we learned how to implement an LFO and change the rate of it through hertz, meaning when we play a note and we decide to change the rate of the LFO, we just move this knob here. And we can change the rate of oscillation that way. We can also change the depth. However, many of us are probably going to be writing electronic music, and we don't want to have to do all this math and divide the number of beats by the number of hertz in our LFO and automate that in our DAW. It'd be really, really tedious and unproductive. So today we are going to add tempo sync functionality to our LFO rate so that we can control it based on divisions of the beat rather than simply hertz. So we're just going to jump right into that. If we go into our instrument panel, go into our LFO macro, you'll notice where we left off here we just have basic controls for rate, depth. We can also set the center of the filter of the range of frequencies we want to be affected. So to get started, we're going to need to make a switch between, because we don't want to eliminate we don't want to eliminate controlling the rate, the LFO rate through hertz. We may also want to use it, I don't know, later for maybe some other sound design project where you don't necessarily need or want the oscillations to land on the beat. So we're not going to delete that. We're just going to delete the wire between it, and we're going to move it over here. And we're going to first add a switch. Yes, let's do that. So built-in module panel switch. Okay, we've seen this before. And we're going to, obviously one of the options is going to be the LFO rate. That's going to go in the switch. And I'm just going to go ahead and connect the switch to our frequency input for the LFO. Okay, we have that. Now we need to add the tempo info from the program. So the tempo info, and as I'm running Reaktor as a standalone program right now, it's receiving the tempo information from here. This 120 beats per minute. That's the tempo information for this particular program. If you open this up as a plugin in a DAW, then it would take the tempo information from the DAW, obviously, and use that in your plugin, which is exactly what you want, probably. So, yeah, let's now we're going to actually introduce a new type of panel item today called the list. And the list is pretty straightforward, and it's exactly what it looks like. You can add things to it, and then you can select from the interface things on the list, different properties. And what it does underneath the hood is, so we can assign labels, and the information that we're going to assign to the list is what divisions of the beat we want our LFO to, what properties we want to give it there. So I'm just going to go ahead and insert append 7 entries, and I'm going to name the first one 1/2, the second one 1/4, 1/4 triplet, 1/8, 1/8 triplet, 1/16, whoops, 1/6, 1/16, and 1/16 triplet. These are, you know, if you have a 4x4 time signature, this is sort of how I just organize the divisions of beats. So this would be a quarter note. If you have 4 beats per measure, then it'll play 4 beats per measure with this quarter note, and etc., etc. If you don't know music theory, you'll see when we get into the DAW. I'm actually going to open a DAW in a future video and show you how to implement this patch here into it so that you can see how it's actually used in a quote-unquote real music production. Okay, so we have our list, and now we need to assign new values. Right now, this one needs to be 0.5. This one needs to be 1, 1.5, 2, 3, 4, and 6. Okay, so I did all the math already and I tested this to make sure it worked. So these okay, so basically when we select an item on the list from our interface, what it's actually doing is it's reading the label that you have selected, and then it's sending a value out of this output here in the structure. So what we're actually going to be doing is we're going to be taking the information up here, which is represented as a different number in, you know, the tempo. Oh yeah, that's right, I forgot to add the tempo information. So built-in module, auxiliary, yes, tempo info, and we're going to actually take this information and we're going to mingle it with this information to tell us exactly how we want the beats to be divided with the LFO. Whoops, I'm sorry. So I'm going to rename this list. I'm just going to call it beat. Or yeah, beat, because that's basically what it is. What beat do you want the LFO to be going at? So now we're going to actually take these two values and multiply them together. So we're going to go into math, multiply. Oops. And do our favorite, I'm just going to move this back a little bit more. Do our favorite drag, hold command, put it as an input, and then rename the switch inputs to on and off. So now when it's switched to off, when our switch is switched to off, it'll function exactly the way it has in the previous tutorial, where the LFO rate that we have set on our panel is what's controlling the frequency, rather than this information over here. So let's just organize this in the panel real quick. Let's move that over. So see, we have a visual display of our beats here. And once I get everything sorted out, switch. Oh yeah, we should probably name the switch, right? To something more meaningful than switch. Let's call it tempo sync. So now we can determine if we want the tempo sync turned on and off. Okay, so I'll just show you real quickly how the list works. Also, I guess what I'll do is I'm going to click on the list here, view, make the height a little bit longer, and you just go into the properties view, and you can set its height there. Oops. There we go. So yeah, now we have a visual display, and we can pick things on it depending on how we want to divide the beat. So I'm just going to make sure real quick that our housekeeping, that everything will actually work. Looks good. So let's actually try this out. Oops. Okay. So right now that's a half note. I'm just going to go ahead and use a quarter note. Tempo sync on. And let's play it. So notice when I move the LFO knob, the rate, it doesn't change it, but when I turn it off, it does. That's our switch in action. So now when it's on, we can actually change the rate at which this LFO works based on tempo. So you're gonna play it's playing at 100 on a 120 beat per minute scale. It's playing a quarter note basically in a 4/4 time signature. And then when we select other things, other tempos or other divisions of the beat, it'll respond accordingly. That's really fast, and this is really slow. So yeah, there we go. And it's, well, now we can, let's actually change the tempo. So right now it's at 120 beats per minute, but I'm slowly gonna just, let's start at 116. And then I'll take the beats per minute down, and this should adjust accordingly. So yeah, it looks like it's working. Now, there's actually another thing I forgot to do in the last tutorial, and I'll do that now. And that's, we're going to use a couple more properties of our LFO here. So we have something called sync and phase. These are what determine when and where you want the LFO to begin its cycle. So the sync is basically, it takes in an on and off. That's all. It only takes in 0 and 1, and it just determines whether or not there's data going into it, which basically determines whether or not the LFO will restart when we I don't know. Basically it determines however we want to, when and how we want the LFO to begin. So naturally, if you think about it, you know that we have a gate that controls whether or not the synthesizer plays a note, it turns on. When you hit a key on the keyboard, the note pitch and the gate are the two MIDI messages recorded into the program, which determines which note do you want to play and how loud do you want it to be played, if at all. So basically, we're going to take the gate input and we're going to, which reads the information from the keyboard, and we're going to tell it to, we want that to be what restarts our wave. So, so we're going to add that. However, sometimes we may not want to restart the waveform. Like if we want it to be smooth and continuous even when we change notes, we might not even want it to reset. That's pretty common. If you're in electronic music, you might use it sometimes. So what we're going to do is simply add another gate, panel, or I'm sorry, switch, and we're going to just name this reset, because this is how we're going to determine whether or not we reset the waveform. And I'm just going to send that to sync. And then all we have to do is add a value that says no, we don't want to reset it, which would be 0. 0 means nothing in Reaktor, or 0 means no data basically in Reaktor. So so that'll be indication that we don't want it to be reset. But if we do want it to be reset, naturally, most of us would probably want to reset it with whether or not we play a note, right? So every time we play a note, we may want to reset the waveform. So we would do this by adding a gate here, and we've already added a gate in the outer modules, but here the nice thing about Reaktor is that you can sort of, you can use all this information any way that you want to, and you don't have to draw everything from one gate input, for example. We can implement it wherever we need to keep things looking nice. So yeah, we're going to add a gate and hold command and add that to our switch, and 0 is our first value, and the gate, I think that it'll save a little bit of CPU if you just set the upper limit to 1 instead of 127, so that it doesn't have to interpret the messages, but that's something you don't really need to do. Anyway, so it knows that, so every time we play a note, the gate input activates, and it's going to send a value to our sync module. And whenever the sync module reads something, it resets the waveform to a part of the phase of the form that we specify. So for example, we can start it in the middle of the waveform or halfway, a quarter of the way through it, but we have to set it through this pH input here. So the sync is determining when we want to synchronize it, which in our case is usually when we hit a note, and then the phase is where on the waveform do you want it to sync to. I just want it to sync to the beginning, that's natural. So I'm just going to go to math, constant, 0. And some people would like to, they may want to be able to adjust this in the programs itself, and programs like Massive would do this, but I'm just going to keep mine simple. So just 0, and put that in the pH input, and we should be ready to go there. Oh, change this to on and off. Actually, I have that backwards, so I'm just going to switch them. I think I have them backwards. Gate. If I want the yeah, that's right. So yeah, sorry about that. Just because I like on and off to be in the correct order. So there we go. Gate on, synchronize it. Gate off, don't synchronize it. Good. That is looking like what we want. So let's see how this actually works in practice. Okay, so right now we have it syncing to a quarter note. Oh, let's move our new reset button. So let's play a note here. Okay. And now when we have reset on, it's actually acts kind of like an envelope in that we'll start the note and then we'll start it again and it'll reset the LFO. But when we turn it off, or here, here's a better example. I'll play it. I'll just tap it really quickly. But notice how it's never dipping in and out, like it does when we just play it continuously. So when we turn off the reset, now it should just continue playing the LFO despite what the gate input from our MIDI message says. hear it dipping in and out even when I tap the note. That's pretty much what reset does, and you would usually turn this off if you want, again, like I was saying, smooth, continuous motion with the LFO without it restarting, despite the note changes. So, there we go. That is basically how to implement beat mapping on an LFO, and in a future project, future video, I'm sorry, I'll show you how this actually works in a DAW, so that you can see it in action. Alright, well, thanks for watching, and we'll see you next time.